All right, the lab that you're supposed to be conducting today is called the decomposition reaction. What this lab does is we start with sodium chlorate and we break it down by adding heat into sodium chloride, which is normal table salt, and oxygen gas. So if we follow along with the procedure, it tells us to measure out and weigh 3 grams of sodium chlorate and place it in a test tube. So I previously had weighed out 3 grams of sodium chloride, so it's going into the test tube right now. Record that mass of the sodium chlorate in the data table, so you can do that now. So your mass for the sodium chlorate is 3 grams. Number 3, it says ask your teacher to add manganese dioxide to the test tube. The manganese dioxide serves as a catalyst for this reaction. It helps to keep this lab a little safer than what it typically would be without. We'll be talking about a catalyst later in the week when I return. So we have this, it's a black powdery substance, and that's manganese dioxide. And again, that's the catalyst. It's kind of messy. All right, so we're putting a stopper, number 4, with the elbow and the tubing on the test tube. Here's our rubber stopper, and we have a glass tubing that allows gas to escape. The rubber tubing is going over the top, and we will be able to collect, hopefully, oxygen gas over in the test tubes over here. We're all the way up to number 6. It says heat the test tube slowly, and this is really critical that you're heating this slowly. Again, the manganese dioxide helps to control the heat and to control this reaction, but we don't want this happening too quickly. Otherwise, we can have some small fires occurring. So this is going to heat over a few minutes. And you'll start to see it melting, which is a good thing. As it's doing that, I'm going to talk about what's going on. The decomposition reaction is occurring slowly. The sodium chlorate is breaking down into sodium chloride and oxygen. And soon we'll start to see it melting, and it might be difficult to see on the video, but we'll start to possibly see a little bit of evidence that there's gas being collected over here. And in a little bit, you'll see quite a bit of evidence that gas is being collected. It's going a little quick for me, so I'm going to turn down the gas to control how fast this reaction occurs. We are trying to collect 2 test tubes of oxygen, and then we're going to verify the presence of the oxygen by putting a glowing splint test into the test tube. We know that oxygen is flammable, so when we do this, you'll see the results of that. Again, we want this to heat up until we don't see any more bubbling. Again, it has to be a controlled heating. So now we're just watching and waiting here. As you can see, I'm wearing my safety glasses and have my hair tied back and following the safety rules of the class. This is when it's getting close to being finished, so I'm trying to watch very, very carefully. Still bubbling, so we're still going to heat this up for a little while. Again, that slow, consistent heat is important in the decomposition reaction that we're doing today, because oxygen is very flammable. You can kind of see this coming out, so we're going to switch it into the second test tube. And we still have a little bit of bubbling occurring. And now it's over. So what we need to do now is we're allowing this whole situation to cool. So I'm going to move the Bunsen burner because I need to relight that so I can do my splint test. And we have to let that cool down, and then we have to reweigh this in order to get the mass of the sodium chloride we produced. And we will eventually be able to figure out what the mass of the oxygen is. Now, when we did our single replacement lab, we were able to hold the test tube upside down and collect the hydrogen. We don't have hydrogen today, we have oxygen. Oxygen is more dense than the air around us, so we don't need to worry about having a top on this test tube. All the oxygen will stay in the test tube as long as, well, because it's more dense than the air around us. If we tip it upside down, the oxygen will then tip out. So we have a glowing splint here. I'm going to come a little closer to the camera here, and when I insert this, you can see that pop. Why does it pop? Because of oxygen. All right, so that was test tube number 1, so you should record the results in your data table for test tube number 1. And we're going to test tube number, we're going to do test tube number 2 here in a second, as soon as I get a little bit, we have to have some glowing embers. We have some glowing embers coming closer again, and you can see that it doesn't work the second or third time because the oxygen has been used up and there's no more oxygen in the test tube. Right, the second part of this is we will need the mass of the test tube after the lab has been completed. So I'm going to grab my hand protectors and get the mass, and you'll have that for your analysis questions. It still is very warm, so I'm taking precaution. So the mass of the entire test tube with the sodium chloride left in it is 32.1. So you'll need that for your data.